Welcome back to Server Virtualization Jumpstart. End of day one, coming to our final module.
You make the title sound exciting.
I do. You got to have a lot of energy behind it.
Well, I understand you're going to talk about quorum soon.
Yeah, we're going to do a little bit of cluster talk on this section here.
I may be dozing down there.
Okay. We'll try to keep it a little more engaging on these basics of quorum.
We would have started, for those of you that are watching at home, we would have started 30 seconds ago, but both he and I completely forgot to plug our cables in here, so we weren't plugged into the matrix.
And we weren't highly available either. Usually one of them should be plugged in, right?
Oh, God.
Oh, there's a cluster joke. Okay.
Oh, Lord.
Well, we'll move on from here, and what we're going to be doing as part of this module is really looking at our availability solutions that we're providing, focusing on failover clustering.
Wait, does that mean you're the redundant node?
Oh, got me. And as part of this, we're going to go kind of end-to-end, look at the different types of virtualization clusters. So we're going to start off by deploying a basic cluster, look at a scale-out file server cluster, look at a Hyper-V cluster, and then look at some optimization around them. So I'm actually going to kick it off, first of all, by jumping straight to a demo on my system, and I'm going to go build you a failover cluster. Now, what we're looking at here is Failover Cluster Manager, and this is basically our Windows Server cluster management utility. Now, when we start to talk about Virtual Machine Manager, you'll see that we have most of these capabilities also available in VMM. So within Failover Cluster Manager, the very first thing that we always do when we build a cluster is we want to make sure it's going to work. And we do this using our built-in best practice analyzer. Now, a little earlier, we mentioned there's a Hyper-V best practice analyzer just for Hyper-V. This is the one that's used for clustering. And essentially, this could be run before you build the cluster, during cluster creation, or even afterwards. And this is actually required for support as well. So if you're going to go run a cluster in production, you're going to want to go and hit Validator Configuration to ensure that it's supported.
Now, as a guy that's built plenty of clusters in production, this thing is invaluable. It really is. Because not only from the standpoint of before you build a cluster, but if your cluster is having an issue,
it's a troubleshooting
first thing you do
tool,
is run validation. And it's going to go through and test everything, like every function a cluster would ever need to do to be able to do it, and tell you what's failing and what's not failing.
So great utility here. And I've personally used this when I've just had trouble using my cluster in my office. I run this validation, and it will tell you things such as, hey, a network cable's unplugged at this port. And sure enough, I've actually had that problem. Somehow a network cable fell out.
I'm curious as to why you have a cluster in your office.
Got a cluster everywhere. I'm Mr. Cluster Guy.
I've got fans and fridges, not clusters.
Way more fun. So what we're looking at here is, first of all, specify what nodes we're going to test. Now, I'm just going to go select a subset of tests here, just for the sake of the demo. We've already gone and run one of these tests ahead of time, and we'll take a quick look through that while this is running.
Now, the other reason, by the way, he's selecting only some of those is because the storage test takes a while.
It can. Essentially, as we're going through this test, we want to guarantee every component works. So this means we test every disk against every node. So as you gradually start to scale up and have 64 node clusters with dozens of disks, it can take a while. Now, in fairness, in the 2012 R2 release, we optimized that algorithm a lot, so it's 3 to 5 times faster than our previous releases. Nevertheless, it can still take a while.
Yes.
So
3 to 5 times faster than 30 minutes is still quite a while.
Absolutely.
And I've had some complex clusters I've built where it's been 30 minutes of validation as it tested every single possible combination. But it's worth it. It really is.
So here's just a quick example where we just looked at the Hyper-V configuration settings and everything passed. But let's take a look at a report we did a little earlier that actually has some warnings and kind of understand what's happening here. Now, first type of configuration that we look at is the Hyper-V configuration. Now, these set of tests are only going to run if the Hyper-V role is enabled on at least one of the nodes. Basically, it's going to go look at all the servers, make sure that Hyper-V is enabled. If it's a guest cluster, meaning it's a virtual machine, it's going to check whether you have the correct virtual fiber channel adapters set. So they're going to take a look at the various resource pools that the cluster's using, trying to make sure we have consistency across naming, sizing, things like that. So one common problem that we used to see was people would go and run a VM on host 1, call it switch 1. They would then go move that VM over to host 2 on switch 2. There's a problem. The VM doesn't understand switch 2. It only understands I need to access through switch 1. So that's just kind of an example of the best practices that we're going to validate there.
In 2012 R2, we've got resource pools that can help with that?
Absolutely. Yep. So we do our resource pool compatibility as well. So we go take a look under inventory. This isn't so much of a functional test. This is really designed as a tool to help enhance your ability to go and really understand what's running in your environment. So this really came as a request from some of our compliance customers, people working with credit card information, financial data, legal documents, government information, medical records, because they often have to inventory their actual hardware, make sure that it's compliant through Sarbanes-Oxley, all those other different types of, PCI, all those different types of requirements to have this type of sensitive data. Now, the nice thing about this as well is anytime you perform an action on a cluster like add a new node, create a resource, we go and create another report for you. So we're always going to keep track, always going to inventory it. Now, under networking, it looks like I have some problems here. We actually have some failures. And what this would mean is this particular cluster wouldn't be supported. So if I go and drill down into my actual test, we get information about the actual IP address. But here we go, is we have some problem with our actual network interfaces here. They do not have matching IP address suffixes, which means that they're not going to be able to communicate correctly.
And what you mean by that is they're on the different subnets.
Correct. Okay. They are on different subnets, so they cannot go speak to each other. So this is something that we want to avoid before this cluster goes out in production.
I've never heard anyone call it a suffix before.
There you go. Use that other terminology here. Then some of the other tests we look at are things such as patches, making sure that you have consistent patches across all of the nodes. Now, a best practice, but not a requirement, is having consistency across these different servers. And the reason for that is so that the VM should behave and operate the same regardless of what host it's on. You wouldn't want to lose a lot of hours kind of troubleshooting an inconsistent behavior of a VM due to some type of difference in the host configuration. So again, while it's not required, it's recommended to have some consistency across the host, both in the hardware and in the software level. So let's go ahead and assume that we've gone and run this full validation test, everything's supported. We can actually create a cluster just with one button. We say, sorry, just one wizard here. We basically say, what are the nodes? So we already entered that when we tested it. And we say, what is the name of the cluster? So we'll call this our Jumpstart cluster. How is our client going to connect to it? Well, I'm actually using DHCP in my environment already. So we're just going to give it a DHCP IP address.
I have a question.
Yeah.
The little checkbox on the bottom, what does that say?
This says add all eligible storage to the cluster.
Geez. And you know, I seem to remember something about that maybe we'll want to kind of address real quick.
Yeah, good point here. So what exactly does add all eligible storage mean? Basically, what we are doing here is we're going to go and look at every node, figure out what disks it has access to, generally shared storage disks, so things such as iSCSI, SMB, serial attached SCSI, or fiber channel. And if we see those consistent shared disks across multiple nodes, we assume that you've masked them and prepared them to be clustered. And so if we keep this enabled, we're going to automatically add all that storage. If we disable it, we could go and manually add the storage later. In this case, I prepared about 7 different disks we're going to use, so we'll go ahead and use the storage. What it's now going to do is check that the computer objects are valid in Active Directory, making sure that I have a unique name, making sure that the DHCP IP address is free, and it should be because we already requested that from our DHCP server. Then it's going to actually go and build our cluster for us, creating networks between the different nodes, using that storage, making that storage cluster managed storage, and then going and basically doing some communication testing, adding some drivers through the file system stack, and basically making these nodes be able to communicate with each other. Now we'll give this a few minutes. In the meantime, we'll jump back to the presentation, let our cluster form in the background, and we'll take it from there later.
All right. So moving on, so there you kind of see the process of building the cluster out, which, as you can see, is pretty straightforward. It's come a long way from the olden days of an engineering degree and certified configurations and whatnot. You can now, while you shouldn't, you can mix and match different pieces of hardware, and as long as all the tests pass, you're good to go.
It's going to be supported.
Now, with so first of all, clustering and Hyper-V go hand in hand. You don't build Hyper-V servers without clusters to back them, because the availability requirements go up and up and up as you add more and more VMs to a Hyper-V host. So if you're going to do Hyper-V, you're going to do virtualization, you have to be able to do clustering, you have to understand clustering. there are two fundamental types of clusters that you've got to be familiar with. One is what Simon's building right now, which is a Hyper-V host cluster. So it's a cluster consisting of more than one Hyper-V server brought together with some element of shared storage. Now, the other type of cluster is an SMB 3.0 scale-out file server cluster. Hyper-V is optimized to work on SMB file shares. And so if you're going to have a file server act as the shared storage, and if you kind of sort of step this back for a second and just think about it a little bit. If you're going to have what Simon's building right now, so what's the storage in your cluster? iSCSI?
Yep, iSCSI.
Okay. So what you've had to do is attach essentially iSCSI storage to all four of your Hyper-V servers.
Correct.
Right?
Start the initiator, point to it, accept it from the initiator. Yep. Kind of a handoff process.
Exactly.
Yeah.
And if you were doing this on Fiber Channel, you'd have a similar sort of conceptual process. If you want to add a fifth node, you've got to go into your storage, and you've got to plumb your storage, attach your storage to that fifth node, bring it in. If you use an SMB file share, you don't have to do any work with storage to add another node. All you've got to do is add the node. Because the file share is already there, and there's no one-to-one mapping between the file share and the host, other than just they're on Ethernet together. They don't even have to be technically on the same subnet. They're on TCP/IP and Ethernet together. You can add another node, a sixth node, a seventh node, and they can just use that shared storage. That whole step of mapping storage vanishes. You don't have to do it anymore. So that introduces the idea of an SMB scale-out file server as the storage point, which is another type of cluster. So we talked about the cluster in a box stuff earlier. That's where that fits into the picture, where you can go in now and create a cluster. The cluster consists of a storage space for shared storage, and then you're presenting file server endpoints. So what I'm going to do is kind of jump into one of those that I've previously created and kind of show you what that looks like. So you've done the wizard. In my case, the wizard's already done and the cluster's is up and running. So I'm using it in production for the demos that I'm running. So here I am in Failover Cluster Manager. I'm getting to Failover Cluster Manager on one of these nodes.
Now, while that launches, Corey, you've been running data centers for 10, 15 years. What storage do you use today?
Today I use a mix of Fiber Channel Direct Attach and Scale-Out File Server.
So you are really implementing this real-world production systems. Is production ready today?
Absolutely. So we use our Hyper-V servers run on Scale-Out File Servers. Period. We don't run anything but Ethernet to our Hyper-V servers.
And would you invest in another storage technology in the future, or you're at least for now that's going to be the?
Well, ask me in the future when I know what my options are.
Theoretical question, maybe.
Yeah. But our file servers are a mix of cluster in a box and traditional Fiber Channel. So just depending on, we're moving towards this cluster in a box model of storage appliances because they're cheaper and easier to manage, and it's easier to just add little blocks like that.
Okay.
So what I've got here is a scale-out file server node. So let me grab the Failover Cluster Manager. I started on the wrong node earlier, so apologize for that. And what I have is the exact same type of cluster, except this is a two-node cluster. This is a cluster in a box. So I've got a single 2U enclosure consisting of two nodes. And then for storage, I have storage spaces providing the storage. And so you can see I've got a number of disks that are available to me. And then these are presented through storage pools, which are generated through the storage spaces engine. You can see the virtual disks, and you can see the physical disks that back it. In order to present a scale-out file server as a cluster object, all I do is I create a file server role. So I've got SOFS01 here. We're going to do another file server. So just check file server type. It's going to be a scale-out file server. Name, SOFS02. It's all DHCP. And we're done. So I've just made a file server object on the network. What I would now do is add shares to that file server. So I come in here, right-click, add file share. Now, this by the way, little kind of behind-the-scenes tip here. When you go add file share, you get that little error. It's got to register the name in DNS. If it doesn't, and if you kind of go try to add the file share too quick, it just hasn't registered in DNS. And the trick to that is just run this command. So I'm going to go to administrative PowerShell prompt, and just do a flush DNS, so an ipconfig flush DNS, just to flush my local cache, and at that point I should be able to refresh this and add a file share. There we go. So little sort of behind the scenes sort of tip for that. And so this is going to run through now my standard create a file share wizard. And what I'm going to do is create an application file share. Okay? And these settings you pick here are just going to defining defaults that are going to be applied later. So there's no real meaning to applications. What makes it application is the settings I'm going to apply later. So I'm going to put this file share on cluster shared volume 1. I'm going to call it ServerVirtHyperVSysCenterM06 cluster shared volume 1. We're going to call it VM2, VM store 2, just to give it a name.
Now, I noticed here that you selected C cluster storage. Now, just for some context here, C cluster storage is actually using cluster shared volumes, this distributed access file system. So important to know with the scale-out file servers, we do have this dependency on cluster shared volumes.
Absolutely.
So just an important note there.
And so because I selected a highly available file server, it defaults to enabling continuous availability. Hit next. It's kind of jumping a little bit on me here with the RDP connection. And now we're at the permissions page. Now, this is an important step, right? So if a Hyper-V server is going to use this file share, you have to grant permission to the Hyper-V computer account. So what I'm going to do is customize permissions, and you would ordinarily use groups to do this. I'm going to just add the machine directly. So I've got two Hyper-V servers in here, HV1, CIB, computer objects. So I've got HV1 and I've got HV2. So I'm just add both of those with full control. HV2, full control. Hit OK on that. And so this is essentially what I need to do to the permissions on the file share. Now, you might think this will get a little bit unwieldy to manage. Well, first of all, you would never generally add individual computer accounts. You put them in a group, you add the group, right? Secondly, if you choose to manage this with a VMM, which you're going to be showing yesterday, VMM will take care of doing all the permissions for you. So if you decide to assign SMB storage to a Hyper-V host as one of the storage options it can use, SCVMM will take care of adding all the requisite permissions for you. There's one other thing you have to do that I'll show you here in just a second. So next on that, hit create, and this is going to go ahead and create the file share. So now what I've got is SOFS02, VM store 2, and I've now got a folder on the network where I can put VMs, right? And that's a scale-out file server. Now what that means is, because the scale-out file server, both nodes are active on this at the exact same time. And if one of the nodes goes down, the disk I/O can transparently move to the other node without any perceived downtime.
So this basically means a node that was hosting that access for that VM can fail.
Yep.
And that Hyper-V could continue VM could continue to run.
Right. It will detect the failure and just transparently move to the other node instantly.
So this is essentially a way to get high availability for your storage access.
Correct. It's the exact same conceptual stuff as you get with, for example, Fiber Channel, where you run multiple Fiber Channel cables from the SAN to your switch, from the switch to your hosts. And if one of those routes goes down, the HBA and the storage adapter know how to just dynamically reroute on the other available paths. Hyper-V and Windows know how to do that over Ethernet now. So if you have two Ethernet cables or two paths into the same storage endpoint, and one of them goes down, it knows how to dynamically reroute without any downtime. And the final thing you've got to consider in here is, because you're using these computer accounts, they have to be enabled for delegation. So all your Hyper-V servers have this requirement of delegation being enabled. So to do that, I'm just going to open the Active Directory Administrative Center, which is the new users and computers. Been around for a couple of versions now. Let's do a quick search for, let's do HV1. Let's do CIB, HV1. And just go open the properties of that computer account. And we've got this delegation tab down here. So click on delegation, and this is set to trust the computer for delegation. This is not the default. When you create a computer account for the first time, it'll be set to not trust for delegation. So when you create the Hyper-V servers, you've got to go in and set this AD attribute and reboot it. Once that's done, you're good to go. You can start assigning the computer accounts access to file shares, which is what allows VMs running on those computers, or those Hyper-V servers, to actually use those file shares. So that's the basics of a scale-out file server for Hyper-V. If you want to get more in depth on things like the multipath, things on how the SMB witness works, and the real details on the file server component, you have a look at some of those other Jumpstart sessions that cover that topic specifically. Because I could literally spend 3 hours on the file server. It's that different. There's that much there. There's that much to look at, and look at how we do failover, how we do multipath, how it does load balancing and teaming, to really make this a powerful, powerful tool. But in terms of virtualization in general, this is the process for building that scale-out file server, same as you just did. Build a file server object, add a file share to it, make sure the computer accounts have access to the file share, make sure the computer accounts have delegation. You're basically good to go.
Sounds good. Well, you spend 3 hours on that. I'll spend 3 hours on Quorum. And we got a whole extra day for everyone.
Oh, dear Lord. You don't want that, folks. Trust me. I don't know who'd warm to death more, you or me. So that's essentially, we talk about using a virtual machine on an SMB3 shared folder. This is essentially what we've just talked about here. Hyper-V administrators, computer account, and Hyper-V host, and then the cluster computer account all need the right level of permissions. For a scale-out file server, there's 2 modes for the file server: scale-out and general cluster. A little kind of, I guess, production tip. Do we like those?
Yeah, production tips.
Production
Sounds
tips.
like a good way to word it. Yeah.
This is going to be really weird. Okay, so you will probably discover this at some point on your own, and you're going to be confused, and you're going to go, something's broken. I did the first time this happened to me. So I've got this VM store 2. Okay, this is a scale-out file server designed explicitly for application data, not for Word documents and PowerPoint documents. And people think, well, it's a scale-out, highly available file server. I'm going to put all my, user profiles on there. Do not do that. It will.
Great point.
It will suck. And here's why. There is no caching at all on this file share, right? No caching at all. So the result of that is when you dump data onto this file share, it's going to be extremely slow. So you sit there and go, I got to, the first time this happened to me, I've got a 10 gig Ethernet connection going to this file server, and I'm uploading data at 50 megasecond. I was sitting there going, okay, what's broken? And what I eventually learned was that because these are designed for application data, there's no write back cache. As a result of that, every transaction is to fully commit before it moves on to the next one. So the result is very slow in end-to-end performance. You run a VM on that same file share, copy data into the VM, it goes at 10 gig a second. Because it's designed for the applications that are running to handle the write caching and all those elements that are involved. So the trick to this is if you're building an implementation like this and you're planning on putting a lot of VHDs on it, little kind of side trick to get the data onto the share a whole lot quicker is you can actually make a second file server on this exact same folder with a different share that's not a scale-out file server, that's a traditional file server, and use that as a way to upload data. So you can upload data through the traditional file share to the exact same end storage location, but then when you create the VMs, you create them on the scale-out file server where they're going to run as fast as they possibly can. So a little sort of a,
good best practice,
behind the scenes, I don't even know if I call it a best practice, but sort of a behind the scenes tip for if you're building this and want to populate it with a lot of data really, really quickly. Now that being said, the file server with R2 now introduces a write-back cache on a scale-out file server to vastly improve write performance in general. Not really a topic for this session here, but certainly take a look at that if you're interested in this whole new generation of file servers. So that here we go. So virtual hard disk. So we already kind of addressed this a little bit earlier, but when you're building out clusters and you're looking at you doing guest clustering, using virtual hard disk sharing as shared storage is a viable option. I'm not going to cover that again. We've covered that already. But certainly using a VHD, if you're going to use shared VHDX as a method for doing guest clustering, the scale-out file server that I just showed you is what you have to put that shared VHDX You can't just throw it on a local disk. It's got to be on a highly available scale-out file server. That's a requirement for using shared VHDX.
All right, so we're going to go in and talk a little more about failover clustering itself, kind of the core concepts, core functionality of how it works. So with this release, 2012 and 2012 R2, we support 64 node clusters, up to 8,000 VMs in those clusters. So these include built-in hardware and software validation tools. Of course, we support the shared storage, but I kind of just want to spend a quick minute to talk about exactly how clusters work. Now, first of all, the key requirement is you need redundancy everywhere. So redundant servers, redundant network cards, redundant path to storage, and then redundant applications supporting it throughout the infrastructure, like redundant Active Directory services. And again, just to eliminate that single point of failure. Now, next key component that we have here is that all of the hosts that are part of the cluster, they're constantly communicating with each other. They always want to understand what is the state of every other node in the cluster. And the reason why we do this is to make sure that if one server crashes and we can't access it anymore, the other nodes in the cluster know exactly what was running on it. So if I had VM1 running on node 1, node 1 crashes, we want VM1 to start somewhere else. And so the way we kind of keep this consistency shared across all of our different nodes in the cluster is actually through the registry. So if you go into a cluster, and we'll switch over to our demo here, I'll show you our cluster that we've already created. Switch over to our cluster here, click Finish. Now we've got our cluster up and running. What we're essentially doing for each of these 4 different nodes in the cluster is replicating our registry. Now, basically, what we store in the registry is every single role in the cluster, the properties for the role, and the state of that role. So, for example, if we have a virtual machine in our cluster, we're going to store the name of the VM, whether it's online, offline, pending, the resources, and basically the properties of those resources. So, names, what they're dependent on, things like that. Now, as soon as one of those resources changes on one node, let's say I create a new VM called VM2, we're going to instantly replicate that information to every other node in the cluster so that we make sure that we have that consistent view. So let's actually go ahead now and create a new virtual machine. Now, what you're going to notice as we do this through Failover Cluster Manager is a pretty consistent experience to doing this through Hyper-V Manager. What it will actually do is go and invoke the new virtual machine wizard from Hyper-V Manager. So you actually have the exact same steps, exact same questions as you go and configure this VM. Now, once this is up and running, we'll walk through this in a second. Kind of the final piece that makes clustering working is our health detection model. Now, what we're basically doing is each node is constantly pinging every other node in the cluster, making sure it's online through what we call heartbeats. If one of those nodes doesn't respond after a certain number of health checks, we consider it down, we take failover recovery actions, and basically what that means is we figure out what that bad node was running, such as VM1 and VM2, and then we go start them else somewhere in the cluster. And this is what protects us from this unplanned downtime. And again, different from live migration where you need both nodes to participate, unplanned downtime, crash happens, we detect the crash, we restart it somewhere else.
From the standpoint of the operating system in the VM, someone yanked the power cord.
Exactly.
And that's the same on all implementations of virtualization. It's the same on VMware, same on Citrix, for example. That if you do have that type of a downtime, that's the way that it fails over.
Absolutely, yep. So let's go back to the demo here, and we'll go through this VM creation process. Same type of information you saw before when we looked at this before with Corey. And we'll call this Jumpstart VM 3. Now, here's kind of one of the tricks here. When you're going and deploying this on the cluster, you're going to want to go and actually deploy it on our cluster shared volume disks. Now, what I actually haven't done so far is I haven't actually gone and configured those disks. So shame on me. I forgot to go deploy my CSV disk. We are going to back up 1 second and go and create a CSV disk. Now, you saw when I was creating the cluster that we automatically added any new cluster disks. And so here I have 7 disks in my cluster. 6 of them are available for storage, and one of them is known as a witness disk. And we'll talk about this a little later. Essentially, what I want to do here is make these disks accessible by all of my nodes simultaneously. by adding them to cluster shared storage. Now, this would be equivalent in VMware world as VMFS, the VMware file system, where we have that distributed simultaneous access. So now that they're CSV disks, we'll go ahead, create our VM, and actually go place it on that CSV disk. Now, while I walk through the wizard, can you just kind of explain what's the benefit of CSV and why did we build it as opposed to the traditional one VM, one LUN model?
Well, what CSV allows is for more than one virtual machine to access the same file system at the same time. And so essentially, the danger in having two nodes access the file system at the same time is that they can overwrite each other's data, right? And so the way that CSV works, it exposes both volumes to all the nodes in the cluster, but it designates one node as what's called the coordinator node. And any metadata activities, such as create file, move file, delete file, that involve the file system, are done strictly through the coordinator node. And that's just a role that moves back and forth dynamically. Once you have services up and running that are just reading and writing from a file, as opposed to creating files, because that's a fixed location and a known location, all the different nodes can actually read and write from those files at the same time. And VHDs are one example of that. So in the case of a scale-out file server, that's what allows it to happen. Certainly, allows more than one role on more than one server to access the file system at the same time. That's kind of a key for this whole scenario to operate properly.
Yeah, I guess one of the key goals of that as well was just to simplify SAN management as well.
Yeah.
Have fewer disks instead of having to try to have like a separate disk per VM. So that if one VM crashed and had to fail over, it wouldn't have to move the disk with
I
it.
had a very healthy debate with a SAN guy a number of years ago about should you have one massive volume on your SAN, or should you purposely carve it up into LUNs and present those LUNs individually?
Now, is this CSV or just independent of that?
In general, right? CSV included. And it was a very healthy debate. There's a lot of, arguing and some fights in the parking lot when we're all said and done. But, his point was that depending on the hardware you're using, the way that the caching on the controllers might work, you might be benefited from having multiple volumes presented. So as opposed to 20, have maybe 3 or 4, because you get more efficient caching on the controller for read and write versus one huge volume that has one cache for everything. So we kind of came to the conclusion that it depends on the hardware that you're using, what's good and what's bad. So again, it comes back to really knowing and paying attention to what you're buying to build these things out, as to what their recommended practices are for their kinds of hardware. Some controllers, the cache might be smaller and less efficient with one big volume, whereas it may support multiple caches if you have multiple volumes.
Great point. Well, let's jump back to the demo here. Now that we've gone and actually enabled our CSV disks, we can go ahead and actually store our VMs on this CSV disk. Now, what you're going to see, no matter what node in the cluster, you're actually going to see a shared namespace under C, cluster storage. This gets created as soon as you go and actually create your first CSV volume. And basically what this does is, it means that a VM running on node 1 can access its data through C, cluster storage, volume 1. But if that VM is now running on node 64, guess what? It gets to use that same file path, C, cluster storage, volume 1. And so it's that consistent access point that allows us to do things such as live migration, have some more flexibility, and just really simplify the management. So let's go ahead and pick volume 1 for our Jumpstart VM. Generation 1 or Generation 2 virtual machine, so the exact same settings you get through Hyper-V Manager. Let's go and turn on dynamic memory. We could go connect it to one of our virtual switches if we desire. Keep it offline for now. Same options with creating a VHD now or later. Install our OS now or later. Click Finish, and this first wizard is going to wrap up, and then quickly you'll see the second wizard here, this high availability wizard. Basically what happens is, as soon as we're done creating the VM using the Hyper-V wizard, we then automatically go and add it to the cluster. If you go click the View Report button, you get again a detailed and documented set of steps for everything that's gone and happened with this new VM deployment. Click Finish. It's going to stay in the offline state, and you have the same management capabilities that you do through Hyper-V. Go click on the settings for this virtual machine. That should look pretty familiar to you. We go enable replication for the virtual machine, going through the same process. So pretty consistent look and feel here.
Absolutely. Now, because you mentioned replication, we're going to come to that in a few minutes. Replication is different on a cluster.
It is.
We've got to introduce something called the replica broker, which will, towards the end of this module, we'll spend a second on that. So I've got that's kind of ready to go here. But that's if you're going to do replication and you're going to do it on a cluster, you need the broker role configured because it's got to be able to replicate regardless of the node that the actual VM is running on.
Think of it as almost a highly available replication service.
Yeah, absolutely.
Fails over between the nodes. So let's kick it back to you and let's continue going through these best practices we have here.
All right, so in terms of continuing along, so we just mentioned the kind of the general description of what the cluster is and how it works. When you have VMs on a cluster, it's not as simple as throwing everything there and leaving it. You've got to start thinking about the VM load you have, how many cluster nodes you have, where you want those individual VMs to run. So for example, the wizard you just went through used the C cluster shared volume wizard. As we've talked about with SMB file shares, you could just point that at an SMB file share.
That's right.
The configuration of the VM, everything will be created up there. So you could essentially do a cluster with no local storage, correct?
Correct.
So that if you look at your cluster, under your storage node, it'd be empty. There'd be no disks.
That's right.
And so when you're creating a cluster, that's new, and that's a new capability. That a storage-less cluster that leverages SMB storage that's managed separately. The virtual machine startup priority. Right? If you have a cluster that goes down, you want to make sure that you bring up, for example, domain controllers first. So it allows you to configure things like which VMs come up first, the priority delays between them, so that you don't have a boot storm that occurs. And this will be more important for infrastructure clusters as well. And then finally, preferred owners. Right? And this is pretty important as you start to balance things out. That if you have multiple hosts, you've got 4 hosts in your cluster. Maybe I've got 16 total infrastructure VMs. I want to put 4 on each cluster to get maximum CPU and RAM performance. I don't want to load everything on one. And there's this rule which is n+1 availability, where you've always got to make sure you maintain enough extra space so that you can absorb 1 node's worth of failures or 2 nodes worth of failures. So as an example, I've had folks go in and build a cluster, but overcommit resources. So, I build a cluster and I've got 64 gigs of RAM in each node, but I spin up 72 gigs of VMs. Well, if one node fails, there's not enough memory to bring everything back up again. So, maybe you look at a scenario where I've got, 72 gigs worth of VMs, but I've got 3 64 node clusters. Now I've got enough extra space that I can absorb those VMs if they fail. And it's all really just good planning, to be quite honest. And how many nodes of failure do you want to tolerate? Maybe you want to tolerate 3 nodes of failure in your cluster and still be able to run everything. The more nodes you add, the less the cost of the cluster becomes because you have less overhead. 2-node cluster, it's really 50%. 3-node, it's 1/3. 4, it's 25%.
Great points. Great points.
And then with the preferred owners, there's a concept called anti-infinity, which you had mentioned earlier. So you want to just kind of talk about that for a couple of minutes.
Yeah, I do. So anti-affinity is basically enforcing VMs with the same type of properties to live on different hosts to avoid that single point of failure. So again, the 2 most common applications we see on this is if you have 2 virtualized domain controllers or other types of infrastructure servers. You don't want them sitting on a single host. You lose that host, you lose your whole infrastructure. Similarly with the guest cluster, right? I have 4 virtual machine nodes. They're all running a SQL database. I want to make sure they're distributed as well because, again, I lose that one host, I'm going to lose my entire guest cluster. So anti-affinity through Failover Cluster Manager is actually a property you configure with PowerShell. When you go and use this through Virtual Machine Manager, there's a nice GUI interface for availability sets. We'll take a look at that tomorrow. And essentially, it's just saying we need to go spread out these VMs across our different hosts. Now, going back to some other properties, I'm actually going to jump over to my demo again here. I'm going to show you quickly some of our VM prioritization. Now, we want to think about prioritization as our ability to go and rank VMs based on importance. And so configuring that is pretty straightforward. Where is it? We go down to our change startup priority, high, medium, low, and no auto start. And we'll cover no auto start in a minute. But essentially, this is saying when we go and start our VMs, or we start our entire cluster and lots of VMs are starting simultaneously, this is going to prioritize which come online first, second, and last. So why would you want to do this? Well, a good example is you have infrastructure servers that need to come online first. They're going to be your high priority. Then critical line of business might be medium. Then other supporting services might be low priority. And then for your human resources department, let's not even try to start it. Let's let our entire infrastructure come online, stay healthy, and only then will we go and start those unimportant VMs. And so that was that fourth option, no auto start.
A pretty typical setup for that, by the way, is domain controllers are high, databases that things rely on to start are medium, and when you get things like Link, Exchange, SharePoint that use the data, or Applicate that use the databases, they go to low, and then other stuff like management and monitoring kind of goes to no auto start. You just sort of bring those up. That's the way we generally operate it. Domain controllers, databases, applications, and then what we call the surrounding components, which are the management and monitoring components, where they don't have to be up for things to be up. Obviously, we don't know how healthy things are, but they, once everything else is up and we're no good, well, then we can bring those up manually.
Right. And another good example is multi-tiered applications. You have the back-end database needs to come online before the front-end website, something like that. But beyond just doing startup and making sure they start up in order, we also honor this when you do things such as maintenance on a host. If you say, hey, I need to go take everything offline on my host, I want to go and drain all of my VMs, what we can actually do is we switch over to this interface here. So we could take a look at the nodes in our cluster. We could select pause a node and drain roles. And this will basically go and live migrate our VMs over to different hosts. And it will do that in a prioritized fashion. Now, in this case, I only have a single VM. That's the one that's going to go live migrate here. And actually, I never even turned it online, so it's going to do an offline failover. But essentially, this helps you prioritize evacuating nodes as well. For example, maybe you have some type of virus. You got to quickly get rid of things, live migrate high importance.
Can you maybe
first.
Address patching of the cluster?
Ooh, patching, that's a good question. A lot of people ask about, what are these best practices around patching? So first off the top of my head, when you look at kind of the default patching policies in Windows Server, first thing a lot of people get themselves into trouble with this is the default patching time is actually set to 3 a.m. on every node. Now, it will be staggered slightly, and in general, you're going to want to disable automatic patching on your node. But if there's a critical patch that comes through, a group policy that's going to force those cluster nodes to install the patch, every node installs it at 3 a.m. and then reboots, you've actually taken down your whole cluster. So first, you're going to want to try to stagger those default times across your cluster.
And well, the thing I was going to add to that is you want to, if you're planning that, you've got to factor in time to live migrate.
Time to live migrate. Okay.
Because if it takes everything 30 minutes to live migrate to get, because you've got very large implementation, you've got to make sure that you build into the time between those cluster cycles time to live migrate all those resources off.
Great point as well. And then the other kind of interesting technology around cluster patching is a component called cluster aware updating. This is a Windows Server add-on role, and what it will basically do is go and patch any type of cluster, whether it's a physical cluster or even a guest cluster. And if it's a physical cluster, it will live migrate the VMs between the different hosts while patching the servers. If it's a guest cluster, it will do a failover within the VMs and patch those virtualized clusters. And if you have a non-Hyper-V cluster, we'll still patch that. It'll just do traditional failover as it goes and moves those applications between the different VMs, different hosts. So that's our cluster aware updating.
Now, in addition to that as well, within Virtual Machine Manager.
Step it ahead a little bit, but absolutely, Virtual Machine Manager also has its own updating mechanism called Update Manager. And that's actually going to patch basically any type of infrastructure server that VMM manages. With the exception of vCenter servers, they use kind of a whole different patching system. But this could go patch your library servers that VMM manages, your cluster hosts. It can patch 2008 R2 cluster hosts that it manages. So basically, it's a patch management solution within VMM. Now, I get a lot of questions. Which should I use, right? They kind of do the same thing. And essentially, they're built on the same algorithm, which is pause a node, so put it into maintenance. This means that nothing will then move onto that node. So basically, the node's locked. We then drain it, live migrate everything off. Once it's completely drained, we're going to go install the patches that are needed from a baseline, so we figure out what patches are needed. If a reboot's required, we'll reboot it. After the reboot, we're going to check that the node comes online successfully, that the patch installation code is successful, and finally, that the node can rejoin the cluster. Once we've gone through those 3 checks, we say patch was healthy, take it out of maintenance mode, everything can come back on, go to the next one. and basically cycle through these clusters.
Absolutely. So, I mean, I think to kind of answer your question, use what you have.
Yeah.
If you just have a standalone Hyper-V cluster and you don't want to use cluster-aware updating, you would want to stagger everything out and maybe even do it manually. If you have cluster-aware updating and you're comfortable with it, use that because it does all the work for you. If you have VMM, use that. And if you want to even go to another level of automation because, maybe there's some custom things you've got to do, that's where Orchestrator can fit in. Now, that's obviously tomorrow's work, but all those levels are available for managing the patching on the cluster.
Absolutely. And, one final thing to mention about cluster-aware updating is it has what's called a self-updating mode as well. And what this basically means is the cluster can patch itself. So you don't need a separate server that's set up to do your patching. What will actually happen is you have your 4-node cluster. Cluster-aware updating will actually be a clustered resource and move between the active nodes and then manage those other nodes that it's not running on. So this basically gives you high availability throughout your patching infrastructure. Now, we actually had one customer that we spoke to. They were part of a large social media network. They have 64-node clusters. And they do regular patching, every week, every 2 weeks. And they have thousands of VMs running across them. And their story is they're just in a basic patching cycle. They say, we don't need to think about it anymore. Once a week, we kick off cluster-aware updating. It takes several days to complete. The environment's dynamic. A few days later, everything's patched, everything's moved, the entire infrastructure is healthy. So if you really want to kind of eliminate that repetitive task, patching nodes, definitely go check out these built-in tools. Now, final thing that I want to next thing I'm going to discuss as a best practice here is around starting up our VMs. Now, as we kind of mentioned earlier, one challenge that a lot of people have with starting up VMs is it takes up more resources than running a VM in production, generally speaking, right? And if you have a high-end SQL database, maybe not. But if you're just running kind of a standard VM, when you boot it up, you get a big peak as the drivers are loaded, file systems loaded, connecting to the network, startup scripts, user roles, Active Directory, kind of a lot of churns going on. So you'll see a spike in CPU, and then gradually it will kind of level off. Now, a challenge that we saw with a lot of customers in our older releases was if they had a cluster that went down and they didn't have prioritization, they would say start everything up. All of the VMs would start up at once. And maybe you had a host that could usually run 10 VMs under standard workload. You're now trying to start 10 VMs at this accelerated workload. This would trigger what we call a startup storm because you're basically over-allocating resources during this startup phase. Bad thing about that, it could cause the cluster to crash.
Yeah.
Everything then fails over to the next node, which is also facing the startup storm, causes that to crash, and then we've effectively created a domino effect, take down everything. Again, that was older version, all updated, all fixed in 2012 due to things such as VM prioritization. Now, the second component around this startup and trying to avoid these startup storms is a feature called persistent mode. Now, persistent mode was something that you had to turn on. It was enabled automatically in 2012, and it was actually exposed in the GUI as a property. In 2012 R2, hid it entirely, it's on by default, and you would only turn it off by actually going through a PowerShell commandlet and purposely disabling it. And what persistent mode is going to do is it's going to automatically start your VM on the last host that it was purposely moved to. So let's say, for example, I have my 4-node cluster. I got 10 VMs on each node. Now, when a failure happens, node 1 goes down, those VMs fail over. That's not considered a planned move. That's considered a failover. Now, if gradually all of those nodes go down and we lose our entire cluster, the problem that we would have is once we start to get some nodes coming back online in the past, all of the VMs would try to go and flood those first 2 nodes that came up, triggering the startup storm, and then causing the same problem. So 2012 R2, with this concept of persistent mode, what we're basically going to do is say, once the first nodes come up, only start the VMs that should be running on there. Only start these VMs on here, these on here, these on here. And what this is essentially doing is it's making sure that the VMs are only running on the nodes you want them to run on. Now let's say, for example, only 3 of our nodes come up. One of the nodes is still offline. Well, those VMs that were waiting on this, that were persistent on this, they are going to come online eventually on a different node, but we're going to wait 2 minutes by default. Now, this 2-minute delay means, yes, your VMs won't start for 2 minutes, but it's going to give these other hosts a chance to start up, get past that startup storm, settle, and then gradually go and add a new VM. So we do recover, but this is just some built-in protection during startup to provide higher availability.
I think that stuff becomes far more important as you build bigger, more complex clusters, because it's very hard for you to manage as a person. So you let the logic and the operating system kind of take care of that for you.
Absolutely.
And it'll, it's the learned experiences of every customer of Microsoft bundled into one package that represent, what collectively is the best thing to do to get this off the ground.
Absolutely. Now, one final setting I want to go through before our VM health monitoring is a concept of preferred owners and possible owners. The way you want to think about this is preferred owner means it's the first place choice for a host. Possible owner, a second place choice. And so we have customers that, started building clusters 5-10 years ago, have some older hardware, bought newer, better hardware, added it to their cluster, and have slightly diverse cluster nodes. Now, you might have a high-end VM that needs, 128 gigs of RAM. Yet your old host maybe only had 64. And so you need to ensure that that particular VM will only go and run on that particular node. So you do this with this concept of preferred owners. You say by default, I want my 2, 4 most powerful hosts to be first place, the preferred owners. Then if we have some others that maybe it will work on it but isn't optimal, we'll say those are possible owners, our second place choice. Now if neither the first place preferred owners, second place possible owners are available, we won't actually start that VM. We'll keep it, we'll basically make it reactive. So if we want to start it, it's available, but it's not actually going to go start on those other nodes. So this gives you some more flexibility in your placement policies as well.
So the final piece we'll look at here before we look at the replica component for clustering is something called virtual machine monitoring. And this is a feature that's built into clusters that allows the cluster to be a little more intelligent about when it chooses to fail over. So it can actually watch services running inside VMs. And if those services fail, it can take actions on the VM on the cluster to determine whether or not it wants to fail it over. So for example, the VM doesn't have to go down, but maybe a service on the VM goes down.
That's right.
And so it can trigger actions like restarting a service, restarting a VM, or triggering a failover on a VM to another node if it happens so often. So it's a way of taking, the cluster can look deeper into the operating system. Obviously you need Windows Server 2012 or later for this to work, but it's not just, is the operating system up, but hey, are all the services actually up? Because maybe there's a network adapter that failed or something, or maybe there's a connection to a database that failed and I've got to fail the other node for that to work. So this is built in. Last sort of big topic for today really is the idea of Hyper-V replica. So when we left off replica, if I can just jump back for a second here, we had done a replica from HV3 to HV4, and then we had done a failover, and we're now replicating from 4 back to 3. What I want to do now is introduce another concept of replica, which is called extended replication. This is new for R2. What extended replication enables you to do is go from you got your primary VM, replicate to your secondary, but then your secondary can now replicate to a third location. And the fundamental request from a lot of customers that drove this is, hey, I want to replicate within my data center, then I want an offsite replica, just in case we get hit by an asteroid or something. So this extended replica allows you to go to a third server with your replica. Now, in my example here, I want my replica, my third replica, to be on a cluster node. So to do that, I've got to go configure my cluster. And so what I'm going to do on my cluster is add a new role, and this is called the Hyper-V replica broker role right here. Hit next. Name, we're going to call this one ClusRepl, because I'm completely not creative at all. And I need to give it an IP address. We're going to go 280. I can't go 280. That'd be wrong. 234. I'm guessing at an IP address. Hopefully that's an available IP address. This is a
Fingers crossed.
Yeah, little demo set. I mean, not my servers. They're your colleague Rick's. They're his servers I'm borrowing. So, Rick, I hope I didn't just create an issue in your network. So we hit next on that. Brought it online, hit finish. So now we've got this additional role called ClusRepl, which is a cluster object resolvable on the network that I can now use as an inbound replication point. And so, bit of luck. So this is online. Right-click on it, and what you're going to see is I now have replication settings. And so these are the exact same settings that I had on the two hosts I did earlier. So enable this as a replica server.
Pretty consistent experience as well.
Use Kerberos, and I'm going to replicate to my cluster shared volume. All right, again, because it's a cluster, I've got to make sure that this actually comes in as a cluster object, so it's got to go on shared storage. So we'll just replicate to this folder right here. We'll hit OK on that. I've got to turn on that old firewall rule on both nodes. So we're going to do that one. So we'll quickly turn that rule on. Hyper-V replica rule. Enable that rule. Use the other node. I'm doing this real quick for those of you that are watching me, because you've seen me do this before. So we're just doing it quickly. So those firewall rules are enabled. Now, if I go over to HV3 and do my extended replication, this is now going to be clus_repl, which is the broker's name. Goes out and verifies it. We can no longer do 30 seconds. We can now only do the next increment up. So if I did my initial replica, by the way, at 5 minutes, 15 will be the next increment I could use. So that would be the only choice I have. So we're going to do 15 minutes. This will be, say, an off-site replication. Maintain the latest recovery point. Send the initial copy over the network. Start doing the replication right away. Click Finish. And away we go. So this is now sending the initial replica. And what that's doing is creating those files on the cluster shared volume. It's creating a highly available VM that's in an offline state that is a replica. The broker is going to keep the replication synchronized so that if I choose to fail over, I'm actually failing over to an already highly available VM. Right? The broker is the role that ensures that, if one of the cluster nodes goes down, because the broker is just a cluster role, it'll fail to another node, replication will continue. But that's the requirement for inbound replica to a cluster. You can see this right here through a little animation as to what actually happens, that it'll actually replicate directly into the broker role. So, live migration. Talked a bit about this already. Let's take a quick look at how we actually initiate a live migration. I've got a VM right now that's running on this Hyper-V cluster. Let me go back to my cluster manager. So initiating a live migration is done through Cluster Manager. You can see, by the way, here's the Server 2 VM that is currently being inbound replicated. It's powered off right now, which is what we want. But we're going to take this DC VM and we're going to run a live migration. So we simply click Move. We've got either quick migration or live migration. We can also do a move storage. Right, so we're going to do the storage migration. Maybe to take this VM's VHDs, as we talked about earlier, move them to another LAN on the SAN. So do move, live migration, and we can do best possible node, which is going to take all those things you just talked about into consideration, what's running on each node, the load, the priority, choose the best one and put it there, or we can select manually a node. I've only got one other node, so it's only got one place to go. Hit OK on that, and away goes the live migration. You can see it's going through that process we talked about. This is the exact same process that we did for the shared. Nothing live migration, except obviously it's going a lot quicker because the VHDs are not going anywhere. It's only the memory state that's actually moving. And so that migration's done. I've now moved that VM to another node. It's on HV2.
Okay, now you mentioned this best possible node thing. I kind of want to spend a minute and explain what exactly is happening there. Now, as you go select best possible node, what we're actually doing is we're going to go and move this VM to the node that has the most free host memory. And the reason why we kind of built this algorithm into the product was based on feedback from Virtual Machine Manager. As you're going to see tomorrow, VMM has a feature called Intelligent Placement that basically allows you to prioritize the importance of your host based on does it have the most free memory, storage, networking, or CPU. And going through our customer analysis, we found over 90% of our customers say memory. Memory is my biggest constraint, probably for you in your data center, right?
Well, I actually disk I/O more than anything, to be quite honest. We've got tons of memory. Memories, it's funny how the world is kind of changing. Memory's getting cheap.
It is.
Disk, as the world moves to SSD, is becoming expensive. It used to be memory. It used to be disk was cheap.
But now you've got storage spaces, though. You've got your nice commodity JBOBs, too.
There are still eMLC SSDs involved at, $2,000 for a terabyte. So storage is not cheap. There's a lot of data center dollars in there.
Well, anyway, we were saying that we do this based on most free memory. And so rather than have our administrators think and, do a constant scan, which node should I go move this to, we automatically constantly track memory utilization. You say move this to the best available node, we'll automatically move it to the node with the most free memory. And if you do a VM maintenance, place it into pause node, drain the roles, it's going to go and move those VMs to the best available node, the node with the most free memory.
So with that pretty much wraps up all the content we've got for day one.
Well, that's great. I definitely wanted to go and touch on two questions that I've seen come up a few times.
Absolutely.
First one is for you, related to replication in Azure. So there's a few questions. First is basically, can we replicate to Azure? And secondly, what is the Windows Azure Recovery Manager?
So can you replicate to Azure? Not directly. The Windows Azure Recovery Manager is, and well, first of all, this isn't my major area of expertise, so please someone correct me if I get this wrong. You can move VMs into Azure using App Controller to keep things synchronized. The Azure Recovery Manager is a set of tools that allows you to have a replica of a VM in Azure, and then in the event of a local VM failure, use that as the recovery option for it.
Great. And then one of the new capabilities, a new Windows Azure service that we're offering with the actual built-in recovery manager, allows you actually to do site-to-site failover and basically manage it from a single location. So, the challenge that we had sometimes was customers would do DR from site A over to site B, but they might lose full access to site A. Could it go trigger over replication? Could it go trigger over failover? Well, what we're able to do is use our Windows Azure and go use that as our single management interface, do full site failovers. So not down at the individual VM level, do it at the full site level. And to learn more about that feature, you could go to our Windows Azure and look at the new Windows Azure services that are available.
So I guess to one point of that question, if the question is, can you use this replica function to replicate to Azure, the answer is no. They don't expose that.
Correct. Now, final question we're going to wrap up here at the end of the day. We've got several questions about how do I upgrade from 2012 R2 up to 2012 R2.
Good news is it's phenomenally better than the upgrade from 2008. So the first thing you want to know about doing an upgrade is that the running state of a VM is compatible. So what you can actually do is you can live migrate a VM from 2012 to 2012 R2 without the VM having to go offline. The save states are actually compatible, which is fantastic. Because what that allows me to do is upgrade a cluster without having to take the VMs offline. So I can migrate all my VMs to one cluster. And actually, can you have R2 and 2012 in the same cluster at the same time?
No, you cannot.
No, you can't. So yeah, what I would have is a 2012 R2 cluster.
Right.
I would have a 2012 cluster, do a shared nothing, essentially live migration from cluster A to cluster B. So from the 2012 cluster to the R2 cluster, the VMs never go offline in that process. Now they're on the R2 cluster. Once all the VMs are there, I can retire, reinstall, reformat, whatever. I had a friend of mine used to call it, nuke and pave. That's the reformat and reinstall. And actually bring those additional nodes online in the R2 cluster. Or, for example, you could shared nothing live migrate from a 2012 cluster to an R2 host, upgrade your cluster, and then bring it from the host back to the cluster without any downtime.
So a few different options you have. Yeah. So within virtualization, key thing is if you're doing 2012 to 2012 R2, live migration is supported. Only up level, you cannot live migrate down level. But if you want to go from an older version, move your VMs running from 2008 R2 or earlier, two different methods you can use here. Actually, there's a few. Two methods we recommend. You can do things such as backup, restore. Can work, maybe not recommended. You might have to do some other fix-ups as part of that. The two we do recommend, though, are a export and import. So PowerShell has a series of scripts that allow you to export the configuration, import it back, assuming you're moving up level. Second thing is if you're doing this through a cluster, there's actually a built-in cluster utility. Used to be called the Cluster Migration Wizard. Now it's called the Copy Cluster Role Wizard. And that'll actually allow you to copy all the resources between the clusters. And Well, actually, if we could switch over to the demo, I'll actually show you one of these quick demos here. So what I have running here is I have my 2012 R2 cluster, got my 2012 RTM cluster, not really doing much, just kind of sitting there. And down here on my new cluster, I'm going to say copy cluster roles. This goes and launches the wizard. And essentially, we just go and point it to the old cluster. It's going to go validate that I have access to my old cluster nodes. It's going to go figure out what roles are currently running on that old cluster. I'll take a minute to load. And then it basically says, what can I migrate, what can I not migrate? And gives me a series of checkboxes similar to the validation reports saying this can be fully migrated, this could be partially migrated, this cannot be migrated, kind of giving you some guidance before you actually perform this operation. So let's take a look at our VM, for example. We'll go migrate that. Well, one challenge that we have here is I got two different clusters. I may have two different virtual network names. So if we detect that the virtual network on your old cluster is not the same as your virtual network on your new cluster, we actually give you the ability to go and remap the names of your network switches. And what this will do is actually go and update the configuration file within Hyper-V, providing it with the new virtual network name so that we can make sure that it's going to be successful. Confirm the settings, copies everything over. Now, some caveats with this. First of all, this is not live, okay? This is not a live migration. VMs will be offline. Because essentially what we are doing is we are copying all of that configuration information, the settings for your VM or your file server or whatever you're migrating, to that new server. But we're not bringing it online yet. Now remember, for each of these different clustered entities, they all need an Active Directory object. That has to be unique. So what we do with the cluster migration is we basically do a clone of it. We keep the original one online, running, so it's zero downtime to your production system. You could go through this migration process, create the copy, test it, look at the migration reports, figure out what will work, what will not work. Then when you actually want to do this in production, you'll do the copy, you offline the old VM, online the new VM. Now, one caveat, this is assuming that you're accessing the same VHD, you do have access to that same shared storage, but you're basically just taking it offline from one node, bringing it online from another node. Now, if you're using different SANs or different shared storage, after you offline on the old one, you'll do some type of file copy, then you bring it online on the new one. But essentially what we try to do is provide this end-to-end solution. But next question I get is, I have a two-node cluster. How do I do this migration? I need two clusters, right, to go from the old one to the new one. Well, believe it or not, you can actually have a one-node cluster. Limited functionality, it provides some restart mechanisms, but we're basically going to use our one-node clusters during this migration. Start with a two-node cluster. We evict one of the nodes, so we just have our old one-node cluster. Create a new one-node cluster on 2012 R2. We then do the migration, send all the files across, do the online, do the offline, destroy the old cluster, upgrade the node, add it back to the new cluster. And so that's kind of this stepping process to go and move your old cluster nodes over to new cluster nodes while using the same hardware.
Fantastic.
Fantastic. Well, we are going to wrap up here right on time. I want to first of all thank all of our support staff that's been available all day. They've done a great job answering questions. It's one of our biggest events we've had today. So thank you everybody that's been online.
Somewhere on the order of 5,000 people watching from various parts of the world. Some of the other 20 people out there answering questions that are coming in at a rate of 250,000 a second.
So great job to our team.
And what we're going to do tonight is we'll take a look through some of the question logs and see if there's anything key that we want to kind of hone in on tomorrow first thing. So today, as you obviously gathered, was all about the core hypervisor and the technologies that rely on it, which is the world that I typically live in. Hypervisors, host clusters, file server clusters, all those topics. As we move into tomorrow, now we start going from the level of the platform and the technology to let's take an enterprise level view of this and how do I start building private cloud enterprise solutions using those technologies, which is where System Center fits into the picture. So we'll be looking at things like Service Manager, things like Orchestrator, DPM, Ops Manager, VMM in a lot of detail, and hopefully start painting this larger picture that virtualization through this solution isn't Hyper-V. Hyper-V is the thin layer at the bottom. It's everything else on top that builds the end-to-end solution.
Absolutely. And final thing I want to point you to are some of our different resources that we have available online. And essentially, we want to provide you with some guidance here. So if this course is not enough, we definitely encourage you to check out the Microsoft Virtual Academy, www.microsoftvirtualacademy.com. Lots of online training. We also have the mock exams and mock courses. So if you actually want to take a 5-day version of what Corey and I are talking about in a classroom with hands-on training, so you actually get a lab environment yourself, that will be coming out shortly.
We won't be there?
We will not be there. I did the 5-day version of this, and I'm happy that I'm able to cut it down to 2. Or you just get like 5 days of clustering, so it's good for you guys as well here. Finally, we'll see you tomorrow. Actually, one last thing. There's still been a couple questions about where do people get their free exam vouchers. Stay tuned. We'll give you all the details on the exam vouchers shortly, but we will be sending an email with all of the information as well. So you will get all this information via email very soon. Thank you once again for joining. Thanks to our Q&A team. Thanks to our production team. We'll see you tomorrow.
See you tomorrow.